soon, so we'll get started, but I'll take it a little bit slow at the beginning. So let me just start with my screen share. And I want to pick off just reviewing kind of what we covered in the first couple of weeks. I know with a week break, maybe we're a little bit rusty. So we're going to just step through the homework, and maybe if there's anything I think that's interesting I want to talk about, we'll go over that. And then we're going to go over the new content for this week, which will be talking about strings in Java. Some of you maybe already know what strings are, but we'll learn a lot about how to interact with them in Java. So the homework from last week was, had two parts. The first was just creating a bunch of different variables with all the different data types that we learned. So over the past 2 weeks, we learned about the primitives, which were like the ints, the longs, the doubles, the floats, the Booleans, the characters. Those are all primitive data types. They're kind of the most fundamental in Java, and so that's why we started with them. In the past 2 classes, we also learned about operators, which were ways to interact with some of these primitive data types, such as adding them together or subtracting, dividing, multiplying, as well as the comparison operators, which dealt with the Booleans, like greater than, less than, equals, not equals, and also the specific Boolean operators and, or, and not. And that was part 2. So we'll get to that shortly. But for part 1, it was pretty straightforward. I think I looked at everyone's submission and it all looked good. So I have Eclipse on my screen and I'll just share it from now. A reminder in the meantime, if you could open up Eclipse on your own computer, that'd be great. We're going to be using it as always, and it takes a little bit of time to start up. But so going over the homework, I'm not going to do all of these, but I think the ones that were a little bit interesting were basically these middle ones, doing the float and doing the character. So with the float, I saw a lot of people do something like this. And that's perfect. So I'm just going to comment this out for a second. And if I run this file, you'll see that we get our output of 0.5, which is what we wanted. So I have 2 questions I want to ask. The first is, looking at this code, we had a specific term for this idea of putting like float in parentheses before some value. It didn't have to be float, it could be any data type inside there. But we had a term for this concept. Does anyone remember what that term was? It was a way to convert types to another one. A hint would be that it's called type, not what it's called, but it starts with a C, the word I'm looking for. Let's see. Let's see, Owen Chu. Do you know what this is called?
A cast?
Yeah, that's great. So it's casting or typecasting. And so this is one way that I told you guys how you could convert data types from one to another. We saw this with like, here we're converting 0.5 to a float. Previously, we might have seen it from ints to doubles or doubles to ints. I mean, convert a decimal value to an integer value. So casting is one way that we can do it. And there's actually more, and we might get to that. But my second question is, well, we're doing typecasting here. Like we're typecasting this float into a float. But why do we have to do this, right? If I take this away, all of a sudden we start having problems. It's kind of required. So can anyone tell me why we have to typecast in the first place? What's the problem without having the typecast? How about Ethan? Can you tell me what's the problem? Why do we need a typecast here?
Or else it wouldn't work.
Could you repeat that? The audio was just a little bit messed up.
It wouldn't work without it?
Yeah, it wouldn't work. That's true. Do you know why it wouldn't work specifically? So it has to deal with like larger data types and smaller data types. So floats are a smaller data type. Do you remember what the other data type was for decimal values that we use?
Double.
Double, yeah. So in Java, when we type decimal values like 0.5, it's automatically interpreted as a double. And the problem is you can't store a double into a float because it's too big, it doesn't fit. And so in order to store it into a float, we have to convert it. And so that's why we have the typecast. The other way I taught you guys how to convert floats to doubles to floats is like this. If you put an F, then Java will be like, oh, okay, I'm not going to use my default. Normally, I'd say this is a double, but since you have this F here, it's basically the same thing as typecasting it to a float. But I'm happy to see a lot of people did it like this way, because it's kind of, this is more similar to other applications of typecasting. And so the F is something specific to floats. This is a much more general idea. So it's good to know. Oops. The other part of this homework, oops, let me find that again, was creating a character with the value T. So I also said you could do this with typecasting. And I saw someone did this, which is great, but we're trying to make a character. So that's char in Java. And when I said typecasting, what I was aiming for was typecasting an integer to a character. So like we can do the simple way of just doing character T, and character is with the single quotes. And this is something important in Java. You have to use single quotes for characters. And if we run this, it'll print out a T. That's perfectly fine. But I tell you guys the ASCII table, where basically letters have actually number values associated with them. So if we look here, T is right here. And this first number is called the decimal value. And that's what we're interested in, so 116. So we can actually get a T by also taking the number 116 and casting it to a char. So here we have an int, and we're using typecasting to convert it into a character. And if we run this, it will also print out T. And of course, if we do like 117, according to our table, that just gives us the next letter. So it should give us a U. Right. Yeah. So that's another way to make characters. I just put it there as a added challenge, but if you did it with single quotes, that's also fine. The other part of this homework dealt with working with this Boolean expression. And so I just made it up. I tried to make it somewhat interesting, as in, you couldn't just put any values and make it true. You actually had to work a little bit to make, to find 3 values that make it true. But we had this expression, and I'm going to comment out this part. We had this expression where if we read it, it looks like a bunch of symbols, but really it's practicing our Boolean operators. So this is our OR operator. This is our AND operator. I think AND is a lot easier to remember because this symbol is always, in English, is commonly used as like the AND symbol, the ampersand. You'll see this representing the word AND, so it's easy to remember. The OR is a little bit harder to memorize, but you'll see it a lot, so it gets pretty familiar. And then we also have the NOT, which just flips things around. So recap, the OR operator means that to make this true, B or C, one or both of them have to be true. So if B is true, then this whole expression is true. If C is true, the whole thing is true. If both of them are true, then the whole expression is true. But if both of them are false, then the whole expression will be false. What if it says in Java, the method of printing is not defined for the type print stream? So print stream is a little bit more complicated. If you're trying to print out things to like right here, I would use this command, put it in chat. You can replace the C with whatever you're trying to print. If you have more questions, you can put another message in chat. But anyways, so if we just ran this directly, we'd see it's false because, for example, we can find one place where this is not true. Well, A and B, A is true, B is true, so this thing is true, but we're flipping it, so it's false. But then it's part of this AND expression, which requires both sides to be true. So this whole thing is false. And it's part of another AND expression. So again, the whole thing is false. So we know it can't be the case that A is true and B is true. One of them has to be false. And so I think the solution was just like this. Let's see. Never mind. I think I got the. It was 2 trues and 1 false. Or maybe I got it wrong, but I actually looked up a solution here. So if you look, it should be A is true, B is false, C is false. And so you could just get this by trying all the values true, false for A, B, and C. There's only 8 possible values that you could get. And so actually, if we just look at why this is false, I believe it's probably right here. B or C negated. And so this is saying, is B or C true? In this case, C is true. So this OR expression becomes true. And then we have a negation. We have the exclamation mark. So that flips it to false. And that's a problem because that false is used in the AND statements, which means it just corrupts the whole expression. So another way you can think of it is AND is really strict. So if you have a single false in an AND expression, it will just make the whole thing false. It doesn't care what the rest of it is. As long as you have one thing that's false, it will just stop right there. OR is a lot more lenient. If the first thing's false, I'll just try to look at the second, right? Only when everything is false, then it's like, okay, I have no choice. The expression is false. So if we do that, true, false, false, then we plug it all in and it becomes true. And so the thing I had on the screen previously, this is something called a truth table. So I just plugged it in here and you can see for all the different possible values, here's the value of the expression. And it turns out here, there's only one answer. It has to be true, false, false for A, B, and C. Yeah, so these variable expressions are pretty important. We're not going to see them a whole lot in the coming classes, but they are very useful to understand. And you're going to commonly use like these OR and operators in your code. But I want to take a moment to pause because that's pretty much a review of the previous class and a little bit of the earlier ones as well. I want to see if anyone has any questions about this material, these primitive data types, these Boolean expressions. If there's anything confusing, I'm happy to go back and talk about them a little bit more. I don't see anything in chat. I don't hear anyone. So if that's the case, I'll pull up my slides for today's class. There are some slides that have been repeated in the previous deck that's already been posted to Classroom, but there's some slides at the beginning of this deck about characters again, and specifically about the idea of Unicode or ASCII. And I don't think it's too important, so I'm not going to spend a lot of time on it, but I want to just mention that there is this thing called an encoding of characters. And the whole idea of it, the why we have it, is to kind of standardize representation of text in computers. So we're kind of privileged that we all speak English, and English is commonly used around the world, but English is not the only language. And a lot of languages have characters in their alphabet or their language that is not so common to us, but we still need a way of representing it in the computer. For example, like if anyone knows Spanish, they have like the N with a tilde on top of it. That's a character in their alphabet, and they need a way to represent that in code, but it's not like on our keyboard. It's a little bit trickier. And of course, with like the Chinese language has a bunch of characters that we need to be able to represent somehow. And so that's the Unicode system. It's basically just an expansion on the ASCII system. So when I say like ASCII table, when I've looked up the ASCII table right here, the ASCII table is mostly just for like English characters, right? You'll see there's only like A through Z and some of the special characters like commas, dots, slashes, numbers, right? But there's none of those other symbols that are important in other languages. So Unicode is just like an expansion of the ASCII system, but the idea is just the same. It gives each letter or a character a specific number that's associated with it. So like character 100 is, I don't know, the D. And the character maybe 500 is the N with the tilde on top of it. And it's even used for like emojis. So maybe the character 2362 is the smiley face emoji, whatever, right? It's just some idea of mapping characters to numbers. And the idea is we want this standardized across all computers everywhere. And so that's Unicode. So that's pretty much all I want you guys to take away from it. It's something that exists. The common standard is called UTF-8. So if you ever see this, this is just a way of representing characters as numbers. What I really want to get to for today's class, though, is the new data type. And it's special not just because we haven't learned it yet, but it's the first data type that we're going to talk about that's not considered a primitive data type. And I'll get into the difference between a primitive data type and not a primitive data type. But that data type is called a string. You may be familiar with this concept from other languages if you have done it. And that's just because strings are a very, very common data type that you're going to use a lot. And so it's really important to understand. And more than that, understanding strings will help us understand a lot of the Java programming concepts. And it can be applied to learn other data types and other things in Java. So we're not really just learning about strings. We're actually learning a lot of related Java concepts and just using strings as a way to see it. Right. So yeah. There's something called Javadoc, and I want to introduce that a little bit. We're not going to spend too much time on it today, though. But I'm going to take this URL, I'm going to put it into Zoom chat. And if we navigate to it, Javadoc is short for Java documentation. And it's just a website that gives you all the information you could ever hope for and more about Java things. So here we have the string type, and it tells us a lot of things about it. Usually when you go to a Javadoc page, the beginning section is more like a paragraph or longer, just describing it in text. So the string class represents character strings. An example of it is just like ABC. And here's how you can make strings and a lot of things that you can do with strings. So it supports the string concatenation operator, which means adding strings together, joining them together. And then you get to the more technical specifications. It's a bit overwhelming. You don't need to know all of this, but I just want to introduce Javadoc really quickly today as a resource for if you want to look at other stuff on your own time. Javadoc has a ton of information about everything in Java. But the important thing is this section called method summaries. And I'm going to talk a lot about methods in today's class and string methods. And you can see a sneak peek at some of them, such as like char at. So this is that's called a method. We'll talk about what that is, but it's a method. And what it does is it returns the character value at a specified index value. And I'll explain, of course, this a lot more in depth later on. But that's just a sneak peek. Yeah, so Javadoc, it's an important resource, especially if you're learning stuff on your own or just want to get more information on how to use something. Javadoc has a ton of information. All right. So let me full screen this. All right. So first of all, how do you make strings? Well, it's pretty simple. It looks similar to how we've made all of our other variables up to this point. The differences are as follows. We have our data type, and this time our data type starts with a capital letter, right? Notice all of the data types that we've learned before, ints, doubles, character, Boolean, they all start with a lowercase letter. But strings start with a capital S. And this is one of the differences between primitive data types and non-primitive data types. Primitives are generally lowercase, and non-primitives start with capital. So our data type, our variable name, that's the same. And then the value, it's very similar to a character, except now instead of single quotes, we have double quotes. And then the semicolon as always. So for example, if I go to Eclipse, and let me make a new class so I can work from scratch. And if you have this on your own computer, you can follow along. So I'm just going to call it class 3. Oops, I forgot to put the main method. So I'm just going to copy it over from another file. There we go. So we can create a string and we can print it out, right? So system, or I have to make it a string first. String, call it my string, and is equal to the value of world. Right. So I make my string, it's in double quotes, and it's automatically highlighted in blue. And we can do system.out.println my string. And surprise, surprise, it just prints out whatever this text was, right? So really basic, strings just contain text information. The difference between strings and characters is that strings consist of one or more characters, or 0 characters. You can have an empty string as well. So it'll be a little bit hard to see, but you can have a string that's empty. And if you run this, it's hard to see because it's empty. So printing out doesn't really reveal anything. But I can promise you that this is a valid string. You can do everything that we're going to talk about with strings with an empty one as well. But yeah, strings. I'll take a moment. Does anyone have any questions about strings? What we talked about so far? All right. Yeah, so this should be mostly familiar. Another thing that you may or may not be familiar with is when I talked about characters, I mentioned that you have the backslash, and that's used to make a lot of special characters, such as, I don't know, the tab character or a new line character. And you can put those inside of strings. So for example, if I put a \t inside my string, this is not going to print out hello space \t space world. Instead, it's going to take that \t right here, and it's going to replace it with a single tab character. And you're going to see that there's going to be a large separation between hello and world now. Right? So if I print it and run it, you can see there's a tab character. Right? So there's a space, there's a tab, and another space. Because there's a space here, a tab, and another space. I could even put like \n, and that's a new line, n for new line. And so if I run this, what it prints out is hello. And then it prints a new line character, which means now the output is on a separate line. It has the tab character, and then it has world. Right? So here's how I can print something that's a little bit weird looking with a string as well. This is a little bit more on the advanced stuff. It's kind of interesting, but not too important. For all intents and purposes, this is considered one character. Right? And this is another character. Right? These are not two characters. It is not a \n and separately. They go together. They're like one unit. So this is a string literal. It's called a string literal because you're literally typing out the value. Something that we do with strings is called working with their index values. And index values are just a way of counting the position, or just numbering the position of different characters within the string. So let's go to something a little bit more simple again. I'm not even going to do hello world. I'm just going to do the string ABCD, right? So this is a string. It has 4 different characters, and each character has an index. Something that this slide says is very, very important to remember. And if you're not used to it, you might forget about it a couple of times, but it's really important to remember because it's the source of a lot of bugs when we're starting out. And that thing is index values start at 0. So when you're counting, it's not like normal counting. We don't start at 1, we start at 0. And so that means this first character, A, has an index value of 0, because that's where we start. Then the B has an index value of 1, the C has an index value of 2, and the D has an index value of 3. So on, so on, so on. If we had more characters like E, F, G, then they'd have like index value 4, 5, and 6. Okay. So really, it's just counting. The only difference is that you start with 0. A consequence of this is that the index of the last letter is exactly equal to the length of the string minus 1. And the reason for that is because we start at 0. So a string with length 1, a single character, the last character is the only character, has index 0. If we have a string of 2, length 2, that means it has 2 characters, and then the last index would be 1 because we go 0, 1, and that's 2 characters. Similar, if we had a 10 long string, then the last index would be 9. Because again, we start at 0. 0 to 9 is 10 different values. All right, so keep this in mind, the idea of indexing characters, because it's going to show up a lot when we work with strings. And it's actually going to show up when we work with other things as well, something called arrays, but that's going to be for a later class. So remember the sneak peek I showed you, the char at method? Well, we're going to use it now. And so if you remember from the Javadoc, is that char at gives you the character value at an index. So you feed in an index and it outputs a character. This kind of idea of feeding in values and getting values in return, that's what a method is. So when we saw that method summary, a method is basically just something that we use, that we give it some values and it returns values to us. It's not exactly, what I said is not exactly true, because some methods don't take values in and some values don't have outputs. But generally it's kind of like that idea. You're gonna use this thing, this method, and it performs some sort of function, some sort of operation, and we like the result of it. So this char at method, it takes an index and it gives us the character at that index. And on the side, there's another method, the length method. It doesn't take in anything, it doesn't need to, and it returns the length of a string. So here we have examples of two different types of functions. The first one has an input and an output, right? It takes in a value here and it returns a value, the character. This is another type of function method. It doesn't take in any values. It takes in 0 values, but it still has an output, whatever the length is. The third type of method, we actually saw examples of the system.out.println method. Well, it's not, it's another one where it has an input and it has no output. You might be confused when I say that, but it has no output in the sense that calling the method, using the method, doesn't produce a value. Instead, it just writes stuff to the screen. So it has some sort of result, but it doesn't have what we call an output value, a return value. But anyways, let's work with these methods, the char at method and the length method. So if we take our string, let's start with the length method, because I think that's easier. It just gives us the length of the string. So here we have our string. And instead of printing my string, I'm going to print out my string dot length. And you know, if you use Eclipse, it's an IDE, so it helps you. So when you start typing LE and so on, it immediately knows that length is probably what you're looking for. And so you can either hit enter, you can click on that, and it'll automatically complete it for you. But yeah, if we run this, it'll say that the length is 7. Lucas, I see you have your hand raised. Do you have a question?
Can I put something in the parentheses for length?
So good question. The answer to that is no. But here I'm just telling you no. But if you were curious about some sort of methods, like can I put something in, can I not put something in? A good resource to find out is the Javadoc I was talking about earlier. So if I really quickly go to this page and I look at all my methods and I try to find length, so it's alphabetical order, and we go to it. Basically, when you specify a method, you specify what inputs it can take. So here, there's nothing inside the parentheses. So it takes no input. You can't put any inputs. Java is strict about that. And I think pretty much every programming language is strict about that. If you define some sort of method that has no inputs, you're not allowed to give it any inputs. On the contrary, conveniently right here, the char@, method is the next method that we're going to look at. This one, if we look at the Javadoc, has an input value. It's an integer value that is called index, right? And this name is not something you have to care about yourself, but it's really more for like giving you an idea of what it's going to be used for. So it's probably going to be the index that's talked about here. But really, you don't need to pass in a variable called index. It's just, this is what the function is going to call it. This is what the method is going to call that value. Yeah, so if it doesn't have anything inside the parentheses, that means it doesn't take an input. If it does, then it does take an input. And if we scroll around a little bit, you can see we're not going to use this method, but this method takes in two values. So it takes an int that it calls begin index, and it takes a second int called the end index. So notice methods can take multiple inputs as well. It doesn't have to take in 1 or 0. It can take in 2. It can take in 10. It could take in 100. Yeah. A great question. Also, just to show it off here, if I put like a value here, it's like 6, Eclipse is going to complain. It's going to say, if I hover over it, the method length is not applicable for the arguments int. And that's because the length method doesn't take in any values. So you can't give it an int. Right? On the other hand, if we do the other method that we talked about, char@, we kind of get the opposite problem right now. If we hover over it, it says the method char@ with int in parentheses is not applicable for the arguments parentheses with nothing. And so what this error message is saying is that this char@ function takes an int, but right now there's nothing in there. We don't give it an int, and so it doesn't know what to do. So if we give it an int, let's, for example, put in 5, right? And run it, it will print out f. And that's because f is the character at index 5. And Lucas, what's your question?
Oh, how about if I go more than the string length?
That's another good question. We can figure out in 2 ways. One is just by trying it. So if I put like 999, right? Notice Eclipse does not complain about this. And that's because it can't really tell you that there's a problem, because in this case, it knows the string is this literal. But in a lot of other programs, the string that you're working with could come from somewhere else. Maybe it comes from something someone typed in, or it comes from a file on your computer. So it really has no information about this string. So it doesn't really know that there isn't a character at index 999, right? For all Eclipse knows, you could have a really long string and it could have something at there. So Eclipse will not tell you that there's a problem here. It will not give you that red underline. However, if you run the program, then you get a bunch of red text. And when you get a bunch of red text, that usually means something went wrong. And you don't need to read all of this, but you can have an idea of what went wrong. It says string index out of bounds exception. So the index is out of bounds, it's too large. The other way you could have maybe figured this out is if we look at the Javadoc again, and we go to char@.
Can you put the Javadoc in the chat?
Yep, I think it is in chat right now, but I can put it again. Yeah, so it's the link, first link in the chat. But if we do char@, you can see that returns the char at the specified index. And the index ranges from 0 to the length -1, right? And it even says it throws an index out of bounds exception if the index argument is negative or not less than the length of the string. So not only does it mess up for values too large, but it also messes up for negative values, because in Java, there's no concept of negative indexes. This is different in other languages. Java chose that you can only have indexes starting at 0. You can't have index -1. You can't have index -2. It's not allowed. Okay. So back to here. A really quick question is, if I wanted this line to print out this C character, what should I give this method as an input? Maybe I'll ask Sophie, what should I give the char@? method so it prints out this character C?
3.
Close. So it is the third character in the string. But remember, when you're doing indexing, what number do you start with when you count for indexing?
Let me.
So if you look at the string, our indexes start at 0. So A here is index 0. So if I tell you that, what should I put here to print out C? 2, yeah. And so no worries about that. It's something that's a little bit annoying, I admit, when you were first learning this, but you always have to remember indexes start at 0, not at 1. And the good thing is, from everything we're gonna do here, it's pretty easy to figure out you did something wrong when you just run the program, right? Because it'll just print out the wrong thing, or it'll just be off by 1, right? And when you see that, you're gonna be like, oh, the index started at 0, it doesn't start at 1. Let me just change all my values and it will work, right? So it's not a big deal if you don't remember, but it is important to try to remember that everything starts at 0 when we're doing programming. So those are two methods, char@, and length. Let me just check my time. We have plenty of time. We can go over a lot of other methods. So for the next couple of minutes, I'm just going to go over a bunch of different methods. Some will be useful immediately, some will be less useful. You don't have to memorize all of these. You can always look them up later, but I just want to get people comfortable with working with methods. So there's 2 more on the next slide. I'm actually going to start with the second one because it's very similar to something that we already did, but just in reverse. So there's something called index of method, right? And so index of is the exact opposite of char@. So char@ takes in an index and outputs the character at the index. Index of, on the other hand, is the opposite because it takes in a character or a string and it tells you where the location is. So again, char@ takes a location and gives you the value. Index of takes in a value and gives you the location. They reverse each other. The only difference is that index of can take in a whole string instead of just a character. So basically, it will just look inside your string for a match to whatever you give it. So it's trying to find, in this case, LL in your string, and it'll tell you the index of it. So doing it on our string, for example, I can do my string dot index of, and maybe I want the index of the letter, I don't know, E, right? Let me zoom out a little bit. So here I take my string, I say dot index of E. So if I run this, it'll give me 4. And we can double check that this is correct by going, well, A is index 0, B is index 1, C is index 2, D is index 3, E is at index 5. index 4. So there we go. Index of is kind of the opposite of char@. It finds the location of whatever you pass in. So that's the basics of index of. Before I get too much further, any questions about index of? All right. So index of is actually a lot more complicated than it might seem. So I gave you the really simplified definition of what it does. It looks for some sort of pattern. In this case, I put E, and it tells you the location of it. But there's a couple important details. For example, what if my string has multiples of that letter, right? What if there's 2 E's in my string, right? Maybe there's 3, maybe there's 4, maybe there's a bunch. Now what does index of return? Well, if we just try it, we'll see it still says 4. That's not a coincidence. If I put an E at the beginning of my string and I run it, now it'll say 0. Right? And notice the other values have changed. The length has changed. The character at index 2 has changed. That's because I've added letters to my string. But hopefully after these couple examples, it should be clear what index of does when there's multiples that match. It just returns the index of the first match. So here, what it does, it starts at the beginning of the string. It goes left to right and sees, does it match what I'm looking for? Does it match what I'm looking for? And the moment it finds a match, it will stop and say, there's the value. If we make it interesting, we could look not for just E, but EF, right? Now there's only gonna be one match right here. Right, so if we run it, it doesn't print out 0 anymore because the beginning does not match EF. Only this part matches EF. And when you put something that's multiple characters long in here, it returns the index where the match starts. So the match is right here, right? EF matches with that EF, but the match starts at this letter, this character. And so it gives you the index 0, 1, 2, 3, 4, 5. That's why it's 5 here. So some additional things about index of. If there's multiple matches, it will return the first one. And if the thing that you're looking for is multiple characters long, that's perfectly fine. It will just return the index of where it starts. I believe if I go to the next slide really quick. Yeah, index of has yet another complication with it. So index of, let's actually go to the Javadoc. There's actually 2 index of functions. One of them takes in a character, it seems like. And here, index of takes both the character and the from index. I think I might be looking at the wrong place. Yeah, okay, so here's what we're actually using. We're passing in a string. So here, index of with an int. So notice the method name is the same. It's index of. But this version takes one input, just whatever we're looking for. This other version takes in 2 things, what we're looking for and a position to start from. So, for example, if I go back to looking for E's, there's a bunch of matches for E, right? There's a match here, there's a match there, and there's 3 matches over here. But I can say, hey, maybe I don't care about matches in the first 3 characters of my string. I'm going to start looking from index value, I don't know, 4. Really, it should be index 3, because if I don't care about the first 3 characters, I want to start looking here. So I want to start looking from index 3, 0, 1, 2, 3. Now, if I run this, it'll give me 5 as the answer, because it says, okay, I'm looking for e's. And so there's 1 e here, there's another e here, and there's 3 e's over here. But you told me start from index 3. So I'm going to ignore the first match. I don't see it because I'm starting the search from here. And so if I start from here, well, where's the first match? It's right here. And where is this located? It's index 5. And so if I started looking from index, I don't know, 6, for example, then it's not going to return 5 anymore because now I've even skipped the second e. It's going to return this one. Right? And this happens to be index 8. So this index of function is actually a little bit more complicated than it might first seem. It can take in a string, take in a character, it can take in a string and a number. If there's multiple matches, you have to know what it does. But if you just play around with it, it should be clear of what it does. And it is very useful. The last thing I want to do is what happens if the index of method can't find what you're looking for, right? So what if I'm looking for x in my string? There is no x, right? So if I run this though, you'll notice it gives -1. So it doesn't throw an error. It doesn't blow up. It doesn't give you that red text. Instead, it just gives you a value that you know is impossible because we said index values are always 0 or higher. So if it's telling you the index of this character is -1, then what it's really telling you is that it doesn't exist. It doesn't exist in the string. Right? So this is something called a sentinel value, which just means it's like it's a alarm. If you ever get -1, that just means it didn't find it. Right? So that's index of. There's another method called last index of, which you can imagine sounds very similar, acts very similar. The only difference is that index of starts left to right, finds the first match. Last index of starts right and goes left and finds the last match in the string. But otherwise, it works the exact same way. So for example, in my string, if I do last index of, and do e, what it's going to find is this match at index 10, because that's the last e in my string. And I can also put in a number. So maybe I want the last index of e starting at index, I don't know, 7. Okay. So index 7 is 0, 1, 2, 3, 4, 5, 6, 7. It's this G. So I'm starting here and I'm going right to left. So I start at the G and I start going left until I find a match. I find it right here. And then what's the index? It's 5. So that's a lot about index of. Now I promise I'm done. Any questions about index of and last index of? So as a sneak peek, these 3 functions, these 3 methods, length, char at, and index of, last index of, these are all going to be on the homework for this week. And I basically made an assignment where you're going to have to use all of these 3 methods to find some sort of value in a string. So I want to make sure everyone understands what each of them does. Checking chat, don't see anything. So in the last 5 minutes, I can go over maybe one more method and then go over the homework assignment in depth. So actually, I'll give 2 methods because they're very similar to each other. There is a method called toLowercase, and there's a method called toUppercase. And you can probably imagine what they do. One converts it to lowercase, one converts it to uppercase. So if I have my string now, let's say A, B, C, D, E, and then A, B, C, D, E. So half lower, half upper. I can say system.out.println my string.toUppercase and my string to lowercase. Right. And so if I print this, let me see the last 2 statements. No big surprise. The first one converts it all to uppercase. The second one converts it all to lowercase. The only interesting thing about this method is the following question. I said it converts the string to uppercase and lowercase, but does it modify the string or does it give you a new string entirely, right? So my original string is half lower, half upper. So when I say to uppercase, does it actually modify this variable? The answer to that is no. It does not modify the original string. So if I print out the original string at the end, just my string, we will see that even after this to uppercase, even after this to lowercase, the original string is still what it was when I created it. Half lower, half upper. Okay. That's not a coincidence. The reason for this is something called immutability. In Java, once you make a string, the value of it can't change. So all the methods that look like it might change it, like this uppercase, lowercase stuff, instead, it just creates a new string that's what it should be. So in this case, it just creates a new string where all the characters are uppercase. And in the second one, it just creates a new string where all the characters are lowercase. It leaves the original one alone. And really quickly with all of these methods, I'm printing out the result of these methods using system.out.println, but you can always store these into variables as you want. You have to be careful about what type of variable you're going to store it into. So for example, the length method is an integer. So you store this into an integer variable. So int x equals the length, right? You can do that. On the other hand, something like char@, as the name suggests, returns a character. So you have to do something like char c equals my string.char@. And last index of returns an index, so that's an integer. To uppercase, to lowercase, well, they return a string because they take your original string and make a new one. So it returns a string. You have to store it into a string variable and so on. Yeah, so based on whatever method you're using, you can store it into the appropriate variable. And so for homework, I'm just gonna go over it. What I want you guys to do is to work with this string I give you. So you can, I'll post this to Classroom. You can just copy it from there or from the instructions. Basically, you have a string inside your code, hello all audiences. And what I want you to do is a little bit like random, but I want you to use the last index of function to find the last index value of the letter A, but not just in the string entirely, starting from index 8. So I want you to start looking from index 8 only. So ignore everything after index 8. Once you find the last index value of this character, I also want you to find the length of the string, x. So now you have 2 numbers. Then you print out the difference between them. You subtract the two values. And then you get a new number. I want whatever character is at that index, right? So recap, you want to find the last index, you want to find the length, you want to subtract the values, and then whatever result that is, I want you to find the character at that index. Hopefully that's clear enough. If you do have questions though, leave a comment in Google Classroom. You can do that privately if you feel more comfortable, or you can send an email. Both are fine. But that's pretty much time for today's class. One announcement before I let you all go is next week's class will be the same time as usual, but it might, just look out for more information later this week. It might be a different Zoom link. If it is, we'll make sure everyone has the correct link for next week, but just a heads up. Yeah.